Hello and welcome again. So today we will learn how to manage our code, okay, or how probably write up our code. So I will take one of my projects here. This document is for one of my projects that I have done before. So you can see here, I will show the different versions of the project, okay, version 1.0D, version 1.2, all the way 3.3 in 1.0.0 and so on. Okay, so these are the pinout of the microcontroller that I have chosen. Sorry, I cannot show you all the data, but this is what I can show you. So you can see here, for example, on pin number 15 here, on the first earlier revisions, I'm not using this pin, but on this 3-in-1 0.0, I need to use it for the switch or load switch. Then on the another or the latest one also, I'm not using it, and so on. So you can see another one also. For example, here for the rotary encoder, one of the revision, I am not using them. Okay. Same goes to here. The first or the early revisions, I'm not using this pin. Then suddenly I use it for the load switch 3. Okay. Or even if I'm not mistaken, here you can see this one, I'm not using them also, then suddenly I use them for the V set channel 1, 2, and 3. Okay, but earlier I'm not using them, or using them for something else. You can see here the electrode switch, I'm using it on pin number 5 first, then on the latest one I changed to pin number 1, then I V set, bring it to, from pin number 1 I bring it to number 5, and so on to the other of the signals. So this one, definitely it will be headache for you guys if you keep manually numbering all the IOs again. Rather than this, we will use something called pre-processing technique to arrange our code probably, and we make our life easy, and the development time will be much faster. Okay, so let's continue the video, and through the video we will learn how to solve this issue and how I managed to solve such issue during my code development. Okay. Now, so I start with new blank project. So let's say I have 3 motors and 2 LEDs, 3 buttons. Okay, so these motors will be connected to pin mode. Yes, I want to use this one. Pin mode, let's say connected pin 2, and this one will be output. Yep, thank you. So I'll copy this 3 times, 2, 3. So here number 3 and number 4, our motor. So this one, motor 1, motor 2, motor 3. That's good. Now we come to our LEDs. Same. I have 2 LEDs. These 2 LEDs, let's say pin number 7, pin number 8, outputs for sure. Now I have this one, LED 1, LED 2. Okay, now we come to my 3 buttons, 3 inputs. This one, for example, I connected pin number 10, 11, and 12. This one for sure will be inputs. These all will be inputs. Okay, So this one will be button 1, button 2, button 3. Okay, so these are, let's say, just roughly, just for the sake of explanation, I will use this number of variables. For sure, could be more, could be less, but let's say only this. Now, for sure, I need to do something for them. Let's say I need to turn them on and off. Let's say for the motors, I will use analog write. Yes, analog write, pin number 2. Let's say the first one will be 500. Okay. And same goes to the rest. Let's say pin number 3. And here is pin number 4. These are the motors. Now I will come to LED. LED, let's say they are just on and off. I don't want to set any PWM output to them. So will be digital write. Here we go. Pin number 7. And let's say this one, I want it to be high or just 1. Will be faster. And this one, just copy paste. This one will be 0, for example, on pin number 8. 0. Now I come to my button. Buttons will be input, so I will create a boolean button 1 equal to digital read. The pin number 10, they start with pin number 10. There we go. So 1, 2, and 3, 10, 11, and 12. So here we go. I can compile it now. Should be everything okay. Done compilation. Okay, so you can see here, guys, I have like 3, 6, 8 signals. Okay, that's contain 3 motors, 3 inputs, 2 output for the LED. So now let's say in this current revision, let's say this is let's say hardware revision, let's say 0.0. okay, I have this kind of signals. Now if I want to upgrade my revision for some reason, let's say I change to, let's say 0.1. 0.1, for example, I want to change anything. So, for example, motor number 1 is not on pin number 2. Let's say I want to change it to A1. Now I need to change here, and I go to here also. I need to change A1, etc. And might be more things to be changed that related to this motor also that need to be changed. So for sure, this is not the efficient way to do it. Okay, now if we compile, it should be compiled peacefully. Yep, done. Okay, so how to solve this issue? For sure, some of you might suggest to use, for example, since the maximum can be like few tens of pins, let's say, so we can use byte. Let's say byte motor 1, let's say equal to number 2, then byte motor 2 equal to 3, etc. Okay, then I will replace the motor with this one. And motor number 2 will be replacing this. If I compile, should be just fine. Okay, so with this, I create another variable, okay, to replace the pin out or to represent the pin out of the motors or the specific pin I'm using. So in the another future, on the next revision, if I change the motor, I just need to change one switch here, for example, A3. Then the rest will be following this variable. But definitely this is not the efficient way. Why? Because we already burned 2 bytes from our memory. or what we call programming memory. So this is not the efficient way. The most efficient way, we use the define, or what we call the pre-processing method. Okay, so here I can say not good way to solve the issue. It's doable, it's workable, however, it's not a good way. So let's come out this one. Now we come to the good recommended way by using pre-processing, or what we call text substitution. Okay, we use hash define. Hash define. Let's say I want to define motor1 equal to 2, and hash define motor2 on pin number 3. This is the most efficient way of doing what we call pin assignments. Okay, with this one we are not reserving any memory, or won't wasting any even single bit of our memory. Why? Because we use pre-processing technique, or the text substitution. So text substitution means while we are compiling our code, so the compiler will come to substitute whenever motor in our code in number 2. Whenever there's a motor 1, we'll replace it with number 2. There's another motor 1, replace with number 2, and replace motor 2 with number 3. Here will be number 3. Here will be number 3. Okay, so these are not variable, they are just text substitution. Okay, they are not variable at all, so you cannot assume them as they can call them as a macros if you know about this. If you don't know, please let me know, I will make another video for them. Okay, so whenever you define here, let's say define LED1, LED on which pin? Let's say on pin number 7. Okay, so now the first LED, you just use LED1. So then the compiler will automatically replace whenever you mention LED1 in your code with number 7 that you change it here. So now if I change my revision easily, I can just put here and say, oh, okay, my LED now not on pin number 7, let's say on pin number 13. Okay, that's easy. So this is the most efficient and recommended way. This is the recommended way to solve the issue. Okay, whenever you want to change here, can be changed immediately and directly without need to touch the rest of your code. Okay, you just need to use hash define, so it will save your memory. Okay, whenever you want to change your pin assignments or IO assignments to any other pin out. Sometimes the customer might request to make the what we call the pin assignment or the IO assignment even much easier, or we don't want to change too many things. For example, if this is a motor LED, they want to keep changing them. Or for another more reasonable reason is they want something called back compatibility. Okay, back compatibility means your code should be work on revision 0.0 at the same time work on revision 0.1 without any major changes. If you do like this, for sure there will be a major changes. For example, here also you have another LED2 on 12, etc. For example, you have like, as I say here, 8 variables, so this one can consider major change for back compatibilities. Okay, so how to solve this issue now? For example, if they now say we'll work on, let's say here we have reached to revision 1.1 already. Okay, with all these changes, now they want the same code to be run on 0.0. Is very headache. You know, you need to change, let's say, how many IOs. So how to solve this issue for back compatibility, again, is easy. We need to define this revision as pre-processing or text substitution again. So here we need to define hash define. We call it, I call it hardware revision. Then we put the revision, let's say 00 or 01 or whatever. But be careful here, we cannot put 0.0, cannot accept float. Okay, so 00, you just maintain 00 here, for example, or you want, let's say 1, 1, okay, which is here, 1.1. So now, from here, we can check the hardware revision, okay? How to check it? We use, again, pre-processing, or we call macros here. If hardware version, yes, or sorry, hardware revision is equal to, what is our first revision? 00. If equal to 00, for example, we do this one. Okay. elif is else if of the macro. elif hardware underscore version, why it doesn't, oh sorry, it should be hash elif hardware version is equal to 01. Then we do something, hash elif hardware version is equal to which one? 1. We will do something else, and at the end we do elif. Okay. So now what we will do, we will copy all our IOs. Okay. We'll copy all our IOs. Then we can check, for example, at the early stage of the design, which is 00, this one was on pin number 1, this one on pin number 2, this one on pin number 5, this one pin 7. The next revision, this one changed to this thing. On revision 1.1, oh, this one being changed to number 12. Okay, this one go back to 3, something like this. Or even you can add on more. Hash define, let's say new IO on pin number, let's say 20 if you have like Arduino Mega. Okay, something like this. So now we can compile. Here we go, Danko Balai. So from here, we can change only this, which is the hardware revision, to control the pin assignment. Okay, so for example, now the customer requests the code to be used for the latest hardware. Then you just need to change this. Then it will follow the latest one, the latest pin assignment. Then you say, oh no, I have something to update for the first revision. No problem, I just need to change the first revision only. Okay, there we go. Then it will be follow back compatible with the first early revision of the hardware. Okay, so this easy. And for sure, this one you can put as much as you want, because this one won't affect the size of your code. It's just a text substitution. It means if this one is being executed, it will only replace the motor with number 1, motor 1 number 1, motor 2 number 2, and the rest will be ignored, and even the first one will not take any size of your own code. This pre-processing technique or text substitution not only can use it for pin assignment, but also can use it inside our code. For example, here I have, let's say, few variables, let's say integer x, y, and z. Okay, this integer x, y, and z, let's say for all of these 3 revisions, but I have these special integers, let's say a, b, and c. These are only to be used with, let's say, revision 1.1. Okay, this one to be used only with revision 1.1. How to do it? Where's the revision 1.1? Here is this. Okay, this is the revision 1.1. So how we do? Here I will define another, I can say preprocessing variable. I will call preprocessing variable. Actually, is wrong to call variable. So I'll call it hash define revision 1.1. Okay, or revision 1_1 should be okay. Call 1.1 better. Okay, let's go 1_1. Okay, so I will define this revision, this variable, or this text. I can say, okay, this text to be more precise. Then down there, I will say if, for sure, I need to start with hash. Whatever we work with preprocessing, we need to start with hash. Hash if, caps lock on, if define this one, then we do this. Hash and if. So now this one will be used only if the revision 1.1 is active or is being highlighted or is being enabled here. Okay, so now we can compile. Shouldn't get any error. So how to test if our code is working or not? I mean, this one is correctly working. I will make any mistake here or any, like, you see some rubbish here. This one should be detected by the compiler. If we run now, it should be detected, but here we go, done compiling without any error, but this is an error, isn't it? If we come back, we see why this one not detected. First, we will see this revision 1.1. Is it defined? Yes, defined. This one under where? Under here, under revision 1.1. Now let's see the hardware revision. Is it 1.1 or no? No, hardware revision is 0.0. So if we change this one to 11, now I believe we should, our compiler will catch, here we go, we'll catch this error. Why? As we come here, our revision is 1.1, which will be activating this section or this block. This one all will be passed. Only this will be enabled. Since this one enabled, this one will be defined. And since this is defined, so this will be enabled again. That's why it will catch this rubbish. So if I change to, let's say, 0.1, now it will pass. Why? Yep. Almost there. Here we go. It's passed. Why? When it comes to 0.1, it's not defined. The revision 1 is not defined. Since the revision 1 is not defined, and I put condition only if defined, only come here. Since it's not defined, so it won't come here. Okay. So this is one method. Now, let's say here also, I have equation, or let's say not equation, let's say function or method to be used or run only, or to be run with all the hardware revisions except, let's say, revision, which revision? Let's say revision the same, let's say, except revision 1.1. Okay, I have this function. Let's say I'll call the function function. This function, okay, I want it to be run with all the codes, all the other revisions, except this one. I don't want it to be run, except this one. Okay, how to do it? Okay, so first I will check for sure if undefined. Sorry, it's not you. If undefined, then I will put my variable. If undefined is, run this one, hash, and if this is 1. Okay, so now if we run, for sure we will get an error. Why we get an error? Let's see. Because here, what is our hardware? 0, 1. 0, 1 will come to here. Is it defined, the revision 1? No. And here our code is if not defined. So it is not defined, so this one will be run. And since we are not declared it, so that's why it gives us an error. So if I declare it here, let's take this one. Let's say just a void fun function. Let's see if this one enough to pass it. Looks so, yep. Okay. Here we go. So now it's running this function. Why? Because it's not defined. It's not defined. So now let's make some error in the function. Let's say just print rubbish. So now it should be detecting this. Okay. Now I will define, or I will trigger the hardware that is defined this variable 1. Revision 1.1. So revision 1.1 should be 1.1. So if I do this 1.1 run, now our fun function shouldn't be run. Here we go. Not only this is not running, but now it's catching here. Let me close this one. Here we go. Why? It's already detected, shouldn't be detected because it's already defined. Let's check again. If this one is 1.1, so 1.1 is already being defined. So if not defined, oh, I guess this one, because it's a function, so it's automatically will come to it anyway. So if I take this rubbish and put it here, now should be pass. Yeah, I guess because it's a function, so the compiler will check the function either way, unless I will teach you some trick now. Okay, let's say now I want to keep the rubbish here. Where's our rubbish? Control X. Okay, I want to keep our rubbish here, but I want this function to be there, but not checking, or how can I say, if not defined, not only don't call the function, but I want to don't include the function in my code. I can do like this. Actually, I can just copy this. If not defined, I don't want you to take this function. See? This is very, very strong, you know. If not defined, if this is not defined, not only don't call it, but don't consider it at all. Now let's change. Let's say to 0, 1. Now we should detect the garbage in the function. Here we go. Why? Because this one is not defined anyway, so that's why it will come and take it. Okay. Yeah, so that's all what I want to share with you guys. So you can see how strong is this. From here we can define our hardware. So now from the hardware only, we can manage our pin assignment or IO assignments. At the same time, we can manage our variables declaration, and also we can manage our code flow. Okay, or whether we want to declare a function or call functions, or even some certain equations that we need to run on one revision but not on another revision. This text substitution, or what we call pre-processing, is very, very strong, or macros overall. Okay, so you can see here we have turned off all this one because we can use this what we call, sometimes we call it a switch. Okay, we can switch it on or off just for the sake of not using this function in one of the revisions. Okay, of the hardware revision, maybe it's not supported, or there's some chipset that's only in the latest hardware but not in the earlier hardware design. Okay guys, so I hope you have learned something new. Please let me know if you need any further explanation or anything not clear. See you soon.